Things are a bit different now with this example, and it is because our denominator has two terms. If you are working problems where you need to rationalize the denominator, one of the most important things you need to do before you start the problem is look at how many terms we have in the denominator, because we have different methods for when our denominator is one term compared to these examples where our denominator has two terms. Okay? Here's what I mean. If we take our usual approach, now I want to make sure that when I do multiplying that I hit every term. That's just a mathematical rule. But I would choose a radical 5 because that's what I see. And what happens when we multiply numerator and denominator by radical 5? The numerator, we end up with 2 radical 5. The denominator, when we do our distributing, radical 5 times 1 is radical 5. Here's where we're doubling up radical 5 with another radical 5 is just 5. And I shouldn't say double because that really means times 2. It's times itself to give us 5. But did the radical get canceled? Not really. It got canceled from our back term, but now it showed up in the front term. This is just showing us that this isn't a good technique for rationalizing the denominator, for clearing the denominator of any radicals. And if you're thinking about now maybe there's some canceling we can do, that would just be wrong. So far, we haven't done anything wrong. We haven't been very productive. But if you're thinking about any canceling, then we'd definitely be doing wrong. Because, why? We would have to be able to divide out from all three terms. A 5, we can divide out from this term. That's outside, but those are inside. So 5 won't work. And a radical 5 we could take from this term and that term, but there is no radical 5 in our third term. So if I remember that when it comes to simplifying a fraction, I need to divide evenly from every single term, then this expression, no matter how many 5s are jumping out at me, I see that there's no simplifying we can do of the fraction. So this method doesn't work. We have to do something different. What we do with these problems when we see our denominator has two terms, we multiply top and bottom by what's called the conjugate. Basically, we use the same terms in our denominator, but we change the sign in the middle. The denominator started as 1 plus radical 5. The conjugate is 1 minus radical 5. That's the sign in the middle is the only thing that we will change to find the conjugate of our denominator. And now let's see what happens when we multiply numerator and denominator by the conjugate of the denominator. We have two terms by two terms, so it's going to be FOIL, and I like to show my steps when doing FOIL with radicals. You could pretty quickly get to a point where you don't necessarily need to write these out. I still like to do that with things that look a bit more complex, but I'm going to do it now to be clear about the steps. Now, FOIL, we're talking about the shortcut for the 4 different multiplications we have to do, and it's not even really a shortcut, just a guide, more like, when we need to multiply 2 terms by 2 terms. There's a total of 4 multiplications we have to do when we do this distribute. 1 times 1, that's our first. The F in FOIL is for first. 1 times 1 is 1. The O is for outer. Our terms on the outside will be the 1 and this negative radical 5. Be very cautious about those signs. Positive 1 times negative radical 5 equals negative radical 5. Our inner terms, will be these two on the inside. Radical 5 times positive 1 is radical 5. And L for last, our 2 last terms, are positive radical 5 times negative radical 5. Be cautious here. We're definitely seeing radical 5 with another radical 5 will give us our 5 outside of the radical, but we have 1 positive, 1 negative. Be cautious that we're making that a negative 5. Now, right after these 4 multiplications, we're looking for like terms, and we have some. Outer and inner, negative radical 5 with positive radical 5. We combine those two like terms, and it equals 0. They cancel each other, and that will always happen when we multiply conjugates. The outer terms and inner terms will always be the same quantity but opposite in sign. One positive, one negative, that add up and equal 0. And often our first and last can be combined also. And in this case, we have a positive 1 with negative 5 is negative 4. So choosing to multiply by the conjugate is the way to clear the denominator when we have two terms. We still need to do the multiplication, this distribute in the numerator. 2 times 1 is the 2, and 2 times this minus radical 5 minus 2 radical 5. The denominator, here are our steps from the FOIL. It's negative 4. But still think about, before we say this problem is finished, can we do any more simplifying? Can we divide evenly from all of our terms that we have here? Well, we have from our first term, there's a positive 2. Our other term in the numerator does have a 2 outside of the radical, and denominator has a negative 4 outside of the radical. So definitely we can divide a 2 out from each of our three terms. And that's going to leave us with this 2 divided by 2, 1. Dividing this 2 out leaves us with just negative 1 radical 5, or the coefficient 1 is often not there, just negative radical 5. Denominator, negative 4 divided by 2, negative 2. That's a great answer. We're done there. Our radical cannot be simplified. The fraction cannot be simplified. There's no radical in the denominator. So our three things that we need to be cautious about in terms of, is our problem finished? They're all taken care of. Let's just add in a little bit more information about some other ways we could write this answer. The negative, first of all, it came from this negative 4 that we found doing the multiplication in the denominator. So I've so far just kept that negative there in the denominator. We know about fractions that a negative sign can be in the denominator, or it can be out in front of the fraction, or it can be in the numerator. But, and here's our last time that we're seeing the importance of recognizing that there are two or more terms, to put our negative up in the numerator, it would be a mistake to just make it a negative 1 minus radical 5, because putting this negative up in the numerator means you need to apply it to every term in the numerator, just like we need to be able to divide from every term, or when we multiply into every term. So moving a negative sign would also need to be applied to every term, and that's what's making this negative 1 and positive radical 5. The negative is changing a negative radical 5 into positive. So I just wanted to point out these other ways that our answer could look and emphasize these important ideas about being aware of how many terms we're working with.